exceed 925. If the EGT ever exceeds 925, you must abort the aircraft. After the EGT stabilizes, continue with the checklist. Engine instruments, check. Ensure that each instrument is within specified limits for idle RPM. The tachometer should indicate between 46.5 and 49.5. No limit is specified for idle EGT, but it must be within the continuous operating range of 140 to 630. The nozzle position indicator should read 77 to 92% open with no fluctuation. Fuel flow should indicate 400 to 600 pounds per hour at sea level, with a maximum allowable fluctuation of plus or minus 25 pounds per hour. Oil pressure should indicate between 5 and 20 psi, plus or minus 2%. However, during cold weather starts, the oil pressure may initially be well above the normal idle range. It may even exceed 55 psi. This condition is acceptable. The oil pressure will return to idle limits as the oil warms up. If the oil pressure is not within operating limits after 6 minutes, shut down the engine. After checking the engine instruments, check the hydraulic pressure. It should be within the normal operating range of 2850 to 3200 psi. Finally, check that all warning lights on the right side of the caution panel are out. This is how the panel should look after starting the number 2 engine. Now for the left engine. Continue to clear and signal the crew chief to divert the air from the right engine to the left engine. Hold your hands clear until you're ready to start the left engine. If the RPM on the right engine was slightly high when you check your engine instruments, it should return to idle limits as the air supply is diverted to the left engine. When the crew chief is ready to monitor the left engine start, clear the intake. Then, give the start signal and repeat the steps we just covered to start your left engine. With both engines started, engage the throttle gate located on the front cockpit throttle quadrant. Now, signal the crew chief to disconnect the air supply from your aircraft. After giving the disconnect signal, hold both hands clear until the crew chief has completed the disconnect and is ready to assist you further. The last step is battery switch check on. On normal battery-powered starts, this check can be performed visually while waiting for the crew chief to disconnect the air supply. If an auxiliary power unit was used for the start, signal the crew chief to disconnect the APU when you signal for the air supply disconnect. After the crew chief has disconnected the APU and the air supply, turn the battery switch on to complete the starting engine's checklist. Okay, now that you have a good understanding of the procedures for a T-38 engine start, here's an example of an actual start, real time.
Are you ready to start number 2?
I'm ready.
We've got a crew chief, fire bottle, and all danger areas clear.
Clear.
Let's signal for air. Hands clear?
My hands are clear.
Starting number 2. There's 14% RPM. Ready, pack. Throttle to idle. Fuel flow is 200. Oil pressure is indicating. EGT rising. 770 feet. Engine instruments look good. Hydraulics look good. Caution lights are out. Crossover is good.
My engine instruments are good. Hydraulics check good. Caution lights are out.
Clear left?
Clear.
Okay, let's divert air to number 1. Hands clear?
Hands are clear.
Ready to start number 1?
Ready?
There's 14% RPM. Ready, half. Throttle time. Fuel flow is 300. Oil pressure indicating. EGT is rising. 700 feet. My engine instruments look good. Hydraulics look good. Caution lights are out.
My engines check good. Hydraulics look good. Caution lights are out.
Throttle gate is engaged. Okay, let's disconnect air. Hands clear?
My hands are clear.
Battery switch checks on. Good start.
You can see that an actual engine start happens fast. That's why it's important that you know every number, limitation, and restriction before you attempt to start.
You've already kicked the tires and lit the fires. Now there are only a few more checks needed to get the wheels in the well. This program will discuss 2 of these checks, the before taxiing and taxiing checks. Since I will follow the checklist, get yours so you can follow along.
The first thing you need to do is set the temperature selector and adjust the canopy defog to the desired level of airflow. This is usually between the 9 and 12 o'clock positions. If the humidity is high and you're night flying or anticipate flying in weather, close the canopies and turn the temperature full up. This will preheat and dehumidify the flight instruments and canopy. Return the temperature rheostat to a comfortable position after the lineup check. If you think you're going to need the pitot heat, check it now by signaling the crew chief. After the crew chief touches the pitot boom, turn the switch on. The crew chief should check both the pitot boom and the AOA vane. After it checks good, turn the switch off. Once again, check the circuit breakers to ensure none popped during engine start. If you're dual, confirm this with the other cockpit. Press the anti-G-suit test button to ensure your G-suit inflates properly. Place the yaw damper switch on. Since we don't have Block 20 aircraft, disregard Step 5. The next thing you need to do is check the flight trim system. Signal your crew chief. Move the trim switch both forward and aft to ensure proper operation of the trim. Then press the takeoff trim button until the indicator light comes on. Check the trim cutout circuit by pushing the stick forward and trimming backward. Then release the stick. The stick should still be in the takeoff trim position. Repeat with the stick aft. Visually check that the ailerons are aligned with the outside of the wing. To check the flight controls, move the stick all the way to the left and right, and visually check the ailerons for proper movement. Now move the stick forward and aft, and check that the stabilator position corresponds. Push in full left, then right rudder. The rudder movement can be checked with the mirrors when the canopy is open. Or watch the crew chief for confirmation of rudder travel. Ensure there is no binding in the rudder pedal. During this check, your hydraulic pressure gauges shouldn't drop below 1500 psi. Now signal your crew chief that you're going to close the speed brakes. Then place the speed brake switch in the up position. Watch the crew chief for confirmation of closing. Give the crew chief the flap signal. And lower the flaps to 60%. Visually check that as the flaps are lowering, the trailing edge of the slab is moving down. Check that the flap indicator is reading a steady 60% plus or minus 5%. Next, place the flap lever in the full down position and check that the flap gauge indicated full down. Return the flap lever to 60% and visually confirm that as the flaps move up, the trailing edge of the slab is moving up. Check for a steady flap gauge reading of 60 plus or minus 5%. Your crew chief will now verify that the slab is trimmed for takeoff. Okay, it's time to do a communication and navigation check. The nav check can be done while taxiing. Next, check your altimeter and ensure your IP does the same by setting in the current reported altimeter setting. With the altimeter function switch in the standby position, you and your IP should be reading plus or minus 75 feet of the field elevation. Now place the function switch to reset. The standby flag should disappear, and the indicated altitude should remain within 75 feet of the standby indication. You should also check to make sure there is no more than 75 feet difference between cockpits in the reset mode. Next, place the fuel and oxygen check switch to gauge test. This will cause both fuel quantity indicators and the oxygen quantity indicator to move counterclockwise. At approximately 1 liter, the master caution and oxygen low-level caution light should illuminate. After noting the movement, release the switch. The fuel and oxygen indicators should return to their original quantities. Now check the crossover relay switch by turning the right generator off. You'll know if you have a good crossover if all right generator associated equipment remains on. If it looks good, turn the generator switch back on. Adjust your seat as required. As a technique, many front seaters lower the seat until the base of the pitot boom just disappears. Make sure your IP does the same. Remove the seat and canopy safety pins. Use caution when removing the pins. Display them to the crew chief and stow them in the storage box by your left knee. Again, use caution when handling the pins to ensure that an engine doesn't try to eat one. Pump on the brakes to make sure you have good brake pedal pressure. While holding the brakes, signal the crew chief to remove the chocks. Now that the before taxiing check's out of the way, let's finish up by completing the taxiing check. Make sure you have taxied clear of the parking area before doing this check. As you maneuver your aircraft, check the turn and slip indicator and the HSI compass card for proper turn indications in both directions. Don't forget to cross-check with the mag compass. The before taxiing and taxiing checklists are now complete. But before you run off, let me offer you a few tips that you will find not only useful, but often required. A throttle setting of approximately 70% RPM should be sufficient to get you rolling out of the parking spot. Once moving, use minimum power settings while in the parking area. Your exhaust could damage other aircraft or injure personnel in the area. When near other aircraft or in a congested area, your taxi speed should be no faster than a brisk walk. Since it's difficult to judge your speed while looking straight ahead, keep glancing out the side of your aircraft to monitor your speed. Avoid the use of brakes and nose wheel steering at the same time. This could result in damage to the nose wheel assembly and tire. If you encounter brake drag or if the nose strut bottoms out, taxi clear of the runway if practical, and request the tug to tow the aircraft. Avoid taxiing a long distance. The instrument cockpit check is required on every flight and is used to check your communication and navigation equipment. You can use the flight instruments check page in your in-flight guide to accomplish this check. On dual sorties, use challenge and response to complete the check. To check your communication equipment, simply call for taxi. If you can transmit and receive, your radios are good. To begin the navigation check, look at the heading on the HSI and cross-check it within 8 degrees of the magnetic compass. If the headings do not agree within 8 degrees, move the compass switch to fast slave momentarily. This will begin a 30-second slaving cycle and should align the heading on the HSI to within 8 degrees of the magnetic compass. When fast slaving, avoid taxiing the aircraft until completion of the 30-second slaving cycle. Next, check your main and standby attitude indicators for off flags or precession. An off flag in the 8 o'clock position of the main ADI will appear whenever power to the instrument fails or is interrupted. Precession in the main ADI can be corrected by pressing and holding the fast erect button, which will erect the attitude indicator at a rate of about 15 degrees per minute. Next, align the pitch trim knob index marker on the main and standby attitude indicators with the reference mark on the case. This should position the miniature aircraft on each instrument approximately 3 degrees nose low, which will provide an approximate level flight indication at intermediate cruise altitudes. Now to check the bank steering bar. Set the steering mode switch to manual and look for the bank steering bar to come into view on the main ADI. Rotate the heading set knob on the HSI and notice that the bank steering bar follows the heading selected by the heading set marker. Remember, this is only true in the manual mode. Return the steering mode switch to normal. Now you want to check your ILS. To do this, make sure you have the ILS frequency for the departure runway set in your ILS receiver. Next, select the localizer final approach course in the course select window and select the localizer on the nav mode switch. Notice that the bank steering bar comes into view on the main ADI and that the CDI shows your relative position to the localizer course. A warning flag at 12 o'clock on the ADI would indicate that the localizer signal is insufficient for this check. Also, if you are within range of the ILS glide slope signal, you will see the glide slope indicator in view on the ADI. Now select ILS and look for the pitch and bank steering bars on the ADI. The ILS is now checked, so go back to TACAN. Finally, you want to check the TACAN. To accomplish this, you can either do the Flight Director System TACAN check described in 51-38, or you can do the TACAN self-test, which is simple and efficient and is used by many IPs. To accomplish the TACAN self-test, tune in the TACAN channel on the field and listen for the TACAN identifier, which will signal once every 35 seconds. Set 180 degrees in the course select window and push the Press to Test button on the TACAN. Notice that the bearing pointer will slew to 270 degrees and the off flag will be in view on the range indicator. After about 7 seconds, the range indicator will indicate 0, plus or minus 1/2 mile. The bearing pointer will slew to 180 degrees, plus or minus 3 degrees, and the CDI will center plus or minus 1/2 dot. This completes the self-test. Now to complete the TACAN check, center the CDI with a 2 indication, and then rotate the course select knob 90 degrees to ensure the to from indicator changes from a to indication to a from indication. Finally, you will want to check the DME at a known ground checkpoint. When doing so, ensure the distance is within 1/2 mile or 3 degrees of the distance to the TACAN, whichever is greater. This completes the instrument cockpit check. You should now set the navigation equipment for your departure.
At each of the flight characteristic maneuvers and address the parameters and some instructional techniques. Bear in mind, we're not going to talk about all of the possible techniques, just a few to prime the pump. When performing all these maneuvers, keep your eyes out of the cockpit and clear. When performing the rudder effectiveness maneuver, remind your students that with the rudder deflected, the unsymmetric G limits apply. One common technique is to accelerate to 300 knots. Pull the nose up to approximately 20 degrees nose high using back pressure to the light buffet, and then use full rudder to roll the aircraft. The aircraft will roll more quickly as AOA increases. Now, re-accelerate to 300 knots, and with the nose approximately 20 degrees above the horizon, unload the aircraft to a half G or less, and use full rudder to roll the aircraft. Note the difference in roll rates. This maneuver can and should be performed at various airspeeds, G-loads, and angles of attack. Be careful not to unload to less than 0 G due to the unsymmetric G limits. Regardless of what technique you use to teach this maneuver, the student should have learned. At high angles of attack, the rudder is quite effective in rolling the aircraft. At low angles of attack, the rudder is not as effective in rolling the aircraft. One common technique used to demonstrate the low-speed aileron roll is to accelerate the aircraft to 300 knots, pull the nose up to 30 degrees nose high, slowing to 150 knots, unload to half G or less, and roll the aircraft using ailerons only. Then repeat the setup, except keep the G load at 1 or greater to maintain a high AOA while attempting the roll. The aircraft will roll, but not as smoothly or controllably. This maneuver can be quite an eye-opener for your student. In fact, it can be performed at any flight attitude in the low airspeed regime. Once performed, your student should be convinced that the ailerons are very effective in rolling the aircraft at low angles of attack. The ailerons are not as effective in rolling the aircraft at high angles of attack. Emphasize during the rudder effectiveness maneuver and low-speed aileron roll that it's AOA, not airspeed, that affects each control surface. Students commonly think that the rudder is more effective due to slow airspeeds. The reason for this is not the slow airspeed, but the high AOA that usually accompanies low airspeed. The stability maneuver should be a real confidence builder for your student. Accelerate to between 300 and 350 knots. Pull the nose of the aircraft up to approximately 60 degrees nose high. Set the power